There we are with Unit 7, Lesson 15, and a little bit of homework help, adding and subtracting with scientific notation. As we got into this lesson, what we learned to be the most important factor when we're talking about adding or subtracting in scientific notation is that the power of 10 must be equal first. The power of 10 represents the place value. So remember the first step, make power of 10 or the powers of 10 equal. Okay, so notice on the first one how it says 10 to the fourth power and 10 to the fourth power. That's a really, really good thing, because that means that when I line these up, I would have 5 times 10 to the, and 3/10 times 10 to the fourth. There's 1, 2, 3, 4. And you'll notice that 4 and 7/10 times 10 to the fourth is the same way. I need to not have that little decimal in there. But what we're after with that is you'll notice that the place values line up perfectly where the decimal point was. The decimal point right here after the leading digit. What that does is it makes sure that all of the place values are lining up correctly, and it allows us to basically take a little bit of a shortcut. You'll notice that when we go ahead and add these together, that we get, if we were just to add in a traditional way, and I hope that this doesn't mess you up by leaving this on here. If we were to add, we just start from the right and work our way left. We see that adding up, these two add up to 100,000. When we have the powers of 10 equal to each other, we can simply take the finite decimal and add that together, and then take that, both of them, times the power of 10 that they hold in common, because what that does, that power of 10 they hold in common says there's 4 place values after each of the 2 decimals. So when we look at this, we look at a value where we get 10, and 10 times 10 to the fourth power is simply equal to 10 to the fifth power. Now, when this says to write your answer in scientific notation using this format, we have to consider the fact that now we have 1 as our leading digit. And so we'd have 1 times 10 to the fifth power. Okay, don't forget that. Don't miss that piece. Always remember this right here. Make the powers of 10 equal first. Then you can add the finite decimals and then adjust for the scientific notation as necessary. That's really cool. That's stayed right here. We'll get rid of that. All right. The next one we see powers of 10 are already equal to each other. So what we can do is we can take 3 and 7/10, subtract 3 and 3/10 from it. Both of them are already times 10 to the sixth power, so that's a really good thing. 3 and 7/10 minus 3 and 3/10 gives us 4/10 that's left over, and so now I have to adjust. I have 4/10 times 10 to the sixth power, but you'll notice that the 4/10 is too small, and so we have to change that just a little bit. We need to make that bigger. And the way that I make this one bigger is much like in subtraction, where if my bottom number is bigger, then I have to borrow from the next place value. So to make this one bigger, I need to multiply this by 10, but that means I have to borrow one of those powers of 10, making this so that we have 4 times 10 to the fifth power. Okay. On the next one, I'm going to leave, hey, my circle's back. The next one, I'm going to kind of leave this one to you to be able to do, but recognize first off, the powers of 10 are the same. So we have 4 and 8/10 plus 6 and 3/10. And these are both being multiplied by 10 to the negative third power. Notice that when you do calculate this, you get a value that is going to be greater than, or the finite decimal is greater than scientific notation allows. So you're going to have to adjust. Pay attention to how you would make that adjustment right there, where you're going to divide by a power of 10, which makes this one right here change a little bit. Okay. The next one that we're after with this one is, again, a similar situation where we have the powers of 10 are already in place. And so we'll get 6 and 6/10 minus 6 and 1/10. And then both those are times 10 to the negative 5th power. We end up with 5/10 times 10 to the negative 5th power. Make sure you adjust that scientific notation so it comes out true and accurate. Okay, I'm going to let you skip over that next one. And we have a little bit of review here. Apples cost $1 each. Oranges cost $2 each. You have $10 and you want to buy 8 pieces of fruit. One graph shows combinations of apples and oranges that total to $10. The other graph shows combinations of apples and oranges that total to 8 pieces of fruit. Name one combination of 8 fruits shown on the graph that whose cost does not total to $10. So you're trying to not get to $10. I'm going to tell you right now that if we're talking about making a combination with apples and oranges, the two of them that you're looking at right here, this is the one, the blue line right here. Whoops. The blue graph right here talks about the pieces of fruit. And the yellow graph right here talks about the money. Those combinations add up to $10. So you have to kind of think about those pieces, and you need to talk about a combination of 8 fruits that does not cost $10. So you've got several options, but there's really one option that you need to avoid. And I would encourage you to think about what color is made when yellow and blue is combined together. And if you don't see green, it's right there. Don't use that one. The next question says, part B, it says, name one combination of fruits on the graph whose total cost is $10 and are not 8 fruits altogether. So basically you're going to get to $10, but it can't be 8 fruits. So you can pick a $10 combination, but you can't have bought 8 fruits. So thinking about this $10 combination, you're going to be looking again at the yellow line as you're looking through this piece. Okay. For number 1, remember you're looking at the blue line. Number 2, you're looking at the yellow line. Part C says, how many apples and oranges would you need to have 8 fruits that cost $10 at the same time? Look for the intersection of the 2 graphs. And it says, now give the number of oranges. I only want the number of oranges, not the number of apples. So be very careful when you look at that intersection for the number of oranges, not the number of apples. Pay attention over here to the y-axis, and that'll get you there. Final part of this assignment for tonight is a little bit of review in solving equations. You need to check your solution. Obviously, that's not going to be given here. And for the purpose of assessments, when you enter your answer here, you will not enter x equals in the answer box. You'll just put the value of x. The thing about checking your solution is once you get an answer, you should check it to know if you're right so that you know if you're right. Right? And this one, our very first step should be distributive property. Make sure that you distribute correctly. -2 times 3x is -6x. -2 times a -4 is a +8. If we go ahead and go over here and say equal, and we go to the right side, we're talking about distributing here first. 4 times x plus 4 times 3, which is 12, and then we'll add 6 to it. And then it's just a matter of combining like terms and then working with the equation to be able to solve for the variable x, getting x by itself. If I may, I would suggest starting with the variables. This one right here could get a little tricky. So what I would tell you is put a little plus sign over here and add the two of them together to get negative 10 times x. What you're left with is 8 on the left and 18 on the right. When you subtract 8 and you subtract 8, you're left with negative 10 times x equals 10. The rest of that's your steps. It's up to you. I'm going to do a little bit less on the next one, but you need to check your solution on those ones. On the next one, we want to distribute again, starting right here with 1/2. Let's go ahead and start by distributing. We have 1/2 of z plus half of 4, which is 2, and 2 minus 6 at the very end. We have a negative 2 times, whoops, I started writing my z backwards. Times z plus 8. What I would recommend on this one is that you do one of two things. You either add your 2z to the half z, or you multiply the entire equation by 2 to get rid of that 1/2. Okay? Eliminating that fraction is one of the things that I've seen people be most successful with, but you don't have to do it this way. And so if I multiply this one fraction right here by 2 by its denominator, I'm going to not only eliminate the fraction, but I'm also going to double everything else that's out there. So half of 2 is 1z. Let's fix that there real quick. Plus 4 minus 12 equals minus 4z plus 16. You notice how every single term on there doubled in its value. And then I can go ahead and finish my steps with that. Just my suggestion there. You don't have to take that, but this is how I would handle it. The 4 minus 12 would be a negative 8. So I'm going to go ahead and put that as a plus negative 8. You could also write that as a minus 8, which is totally fine. And then from there, it's all up to you. I would start right here by adding my 4z to this side, and then my 8, I would add my 8 to the 16, do some division, get z by itself. And then the last one on here, I'm going to leave that one entirely to you, but I would start with my variables just because that's something that I'm used to doing, and that's what I tend to start with first. So there's your homework help. Let me know how I can help you. Make sure you have a great day.